In the previous lecture, we know the air properties like the pressure and the density and temperature changes along the altitude, but also the air properties changes at different latitude. For example, the tropopause has significant difference, for example, at the pole and at the equator. So we need to introduce the international standard atmosphere. So we use it as a standard. Due to the variation of atmosphere conditions with time and location, agreement has been reached on a standard atmosphere to define the conditions prevailing for most of the year for aircraft operation up to an altitude of 30 kilometers in temperate latitudes, for example, the Europe and North America. So the international standard atmosphere is defined by pressure and temperature variation with altitude from a fixed mean sea level datum. And on the right-hand side, we can see the red curve is for the temperature and the blue curve is for the pressure. And the pressure and the temperature both changes along the y-axis, which is geometric altitude. So this curve follows the variation of the international standard atmosphere. And on the right-hand side, again, we can see the division of the layers. First, troposphere, and then stratosphere, and then mesosphere, and finally the thermosphere. And we can see the aircraft, our aircraft mostly cruises at the stratosphere, and also we have the weather balloon, and which we've already seen the highest jump in very close to the stratopause. So this is a variation of the temperature and the pressure. We will have a closer look how what kind of rules it follows. ISA, International Standard Atmosphere, is a static atmospheric model of how pressure, temperature, density, and viscosity change over a wide range of altitudes. So first of all, let's look at the temperature. From 0, which is a sea level, to 11 kilometer, the T temperature decreases linearly. So we can, if we focus on the temperature curve, which is red from 0 to 11 kilometers, and it follows a linear, but in that range, pressure is not following a linear decrease. Again, for temperature, we can see from 11 kilometer to 20 kilometer, temperature is constant. We take it as constant, which is in the stratosphere. Okay. And the International Standard Atmosphere, ISA, contains the following parameters: temperature, pressure, density, and sound speed, dynamic viscosity. And we can see the temperature closer to the sea level is higher than the stratosphere, right? So I give you a question: will the speed of sound the same? Give you 1 second. The answer is no, because the speed of sound, sound speed, is related with temperature equals square root kRT. So if you have the aircraft flying at a lower altitude, and it also flies at higher altitude, and if it's the same Mach number, because of the sound speed at the higher altitude is smaller, so it's slightly less velocity than in the lower altitude. Okay, so here is a table showing the international standard atmosphere, and on the right hand side is a diagram which we can see this apart from temperature and the pressure, we can also see the speed of sound and the density. So the speed of sound changes accordingly with the temperature. Okay, so now let's look at one important milestone, which is 10 kilometer, and that's where the linear decrease of temperature will terminate, and above 10 or 11 kilometer, the temperature will stay the same, will be constant, as highlighted in the box, dashed the red box. We can see the temperature remains minus 56.5 degrees C. So that's the international standard atmosphere, and we just need to remember the definition, why we need to introduce such a standard, and how especially the temperature changes and the pressure changes. And also we need to notice in Mach number, definition of Mach number, and if they have the aircraft flying with the same Mach number but at different altitude, it might have different speed. Okay, the International Standard Atmosphere ISA model is standardized set of reference parameters at different altitudes, but local weather and the climate will influence the actual temperature and air pressure. So here is two diagrams. One is for the winter months from December to January, and the other is May to June. Summer months, we can see the temperature, how the temperature changes. In the winter months, which is the left figure, and most of the temperature is lower than a standard ISA model. So, and in the summer months, it's kind of fluctuating around it. So this is a difference, and we can see a different latitude, right? The temperature profile varied from the standard in the ISA model.